got desperate. Yeah, just a good sleeping bag and a flask of coffee maybe.
Accommodation.
Yeah.
By then again.
Because then you have your funnels and stuff.
Yeah.
Well, anyways, don't forget about the park. Just keep that in mind.
Or a hostel.
or a hostel.
I'm really happy.
But I'd take my chances in the park.
Yeah, because it's free.
Yes, that too. And you know, come June, it'd be quite nice at night. You know, it wouldn't be so cold. So, yeah. And it would only be dark for a few hours.
I'm considering.
You know, sunrise would be at about 5, 6 a.m. You know, so.
I'm considering it now.
It's too early. It's still too cold at night. Not yet. Right. Which lesson were we on? Principle of moment? No. We're way past that.
Principle of moment.
Yes. Yeah. This is it. Took you ages to get up here. How slow were you walking? I had enough time to get up here, set up everything, have some coffee. Anyways, we're just continuing where we left off last time on the principle of moments, which I think, let me see, we did that. We did this. We did the seesaw. That's where we finished last time, the seesaw. Yeah?
The answer is wrong.
Oh yeah, you got a different answer. So I said I'd check what you did.
This one is yours.
Huh? That's mine. Never seen it before. Hey. When I was doing the seesaw question last time, Fawon got a different answer to me, so I do wonder if I wrote something down wrong, or I mean if I made some silly mistake when I was rearranging my equation. But we can easily check that. Easily. Do you have the equation in front of you from last time? This is what I'm thinking. Do you have the equation? Oh my goodness, you wrote it down? I don't know if that last part, I don't remember writing that.
Which point?
Have you got the equation written down from last time for the seesaw question? I suppose you don't.
Oh yeah, this?
I wrote it in his notes.
Indeed. That's the same as Wong's. So what I'll do is I'll get the program to solve it, just to confirm the answer. G is 9.81. 40G x equals 2.5 minus x 100g plus 2.5 plus 2.5 minus x times 30g. This was the equation we had last time, which we had to solve. The answer I got was something like 2.08.
For x?
Yeah.
06.
What was it?
06.
Okay, well I was just from
Yeah.
memory. So I possibly made a mistake here, and we'll know for certain now. Yes, thank you, Flan. So it should be 2.35, not 2.06.
Well, what is it? Is it the calculation?
I must have hit something wrong in the calculator, something stupid like that. If you watch the video, you can leave a comment when you spot the mistake, and there'll be a small prize for you.
Where's the fry?
I know, I'll tell you after you find the mistake. It's a surprise.
What if it's a surprise test or like a surprise homework?
And they story.
No. I'll tell you it won't be that. Okay, thank you for spotting that. So 2.35 should be the answer for X, which means the father should move it 15 centimetres to the left. So the correct answer is 15 centimetres to the left and not what I said last time, 42 or something like that, wasn't it? Yep. So like I said, comment when you find a mistake and you will be rewarded.
Comment on the video.
Yeah. Yeah.
We will be.
Sign it LOLs as well.
What?
LOLs.
Okay.
I'll know who it is then. Okay, shall we continue? Yep. So let's have a look at another example. So again, I'll do it, but I'd like you to try and draw it first.
I wanted to ask you on this one.
Okay. Oh wait, which one?
The lift question.
The lift question. Oh yes. Is that number this one?
No. Maybe. Wait.
What? Oh come on, Swan, draw something.
Chapter 10, question 4. I solved it in a different way, but the answer is the same. So can I use this way?
What was the question?
She goes on a lift, and the lift is accelerating 5 meters per second square upwards. What's the action force?
You asked me, believe it or not, that's the second time you've asked me this question.
I don't remember your answer.
Okay, I'll remind you. No, was the answer first time you asked me. It works out as the same, but not for the right reason.
Just what I did is finding the net force. And then
Yeah, so you said the force, this is her mass.
Yeah.
This is not her acceleration.
This is the total acceleration.
No, no, no. We've had this discussion before. In fact, if you watch the videos, you will hear the same discussion. Her acceleration is 5 upwards. This is her net acceleration, not 9.81 minus 5. Does this conversation seem familiar? Deja vu, perhaps? No, okay. Well, I promise you, watching the videos, you will hear the same conversation. That her net acceleration is 5. This is not her acceleration. It works out to be the same number, but not for the right reason. Therefore, in the exam, this would not be accepted. I think this is the question you're asking me, correct? You want to know, I got the same answer, but is it valid? Right?
Kind of.
Alright.
But because I also used the same method on a different question that I tried online. And then
Yes, you're getting the right answer, and doing these problems this way will always give you the right answer, but for the wrong reason, which makes it no good for the exam. Because the reason the method works is not the reason you think it works.
You mean 25 from where?
Yeah.
And
From the beginning.
I could, if I could think about it for a little bit, I could change the question in such a way that this will not work. So it's only working for some of these problems you're doing, but it's not working for the reason you think it's working. So I could make a small change to it to make it not work anymore. I'm thinking something like if she was being supported slightly by a cable from the ceiling, I could make some small change to it.
Subtract the tension from the cable and then.
Yeah, but how would you get the tension then? You see, and then it becomes much more. You have to do much more. It's not going to be just like this. And where would you subtract the tension from? And the tension has a force. Doesn't the force have an acceleration? You know, it's just not it. I'm sorry. So you're allowed to ask me this question one more time, and then any further asking of this question will be ignored. Okay? Right, have you drawn this? Yep. Fuan, have you drawn this? Show me what you drew.
What's a Grammy?
It's a typo, that's what it is. And it's a gram, you know it's a gram. It's not 100 Grammy Awards. Looks okay. You've broken my train of thought. Right, I'm drawing this now. A 100-gram meter stick is held by two strings, one at the 25 and one at the 90 mark. So what you have here, you have a meter stick. Guess how long a meter stick is? Funny that. And then here you have a string, and this is at the 0.25 mark, wasn't it? And the other one was at the 90. So this distance here is 0.1, you want. And there's a weight in the middle, that's at the 0.5 mark. I'll put 0.9 here instead. And this weight is 0.1 G. And this is some force, we'll call it R, and this force, we'll call it S. It's not moving, which means the force is acting up
0.1 G or K?
0.1 G for gravity.
Oh, okay.
This comes from me saying the forces acting up equal the forces acting down. Is this enough? No, of course not. We need another equation. What's the second equation we can form?
0.5.
Yeah, what are you doing there? The clockwise...
Minus the anti-clockwise.
Well, I prefer to say the clockwise turning force equals the anti-clockwise turning force. So we can say now, next, the anti-clockwise turning force equals the clockwise turning force. It's not rotating. Yes? Now, where is the fulcrum? Fuang, what does the word fulcrum mean? I'm sorry to pick on you, but I think it'll be good for you. What's fulcrum?
Fulcrum.
Yeah.
It's turning point.
See, we believed in you, and it paid off. Good job. And tell me this: where is the fulcrum?
I will to ask.
You will use here.
Mm-hmm.
Yeah. In fact, you are allowed to use any point as the fulcrum in the diagram. Why did you choose or? Good choice. Why?
Because at the 0.1 G, so
Go on.
The 0.1.
No. Your English is beautiful, so you can be quiet. Let her speak. Go ahead, Fuang.
because we know the distance
From where?
0.5
Yeah.
and the 0.1 G,
Yeah.
and then the distance of
Yeah. But why pick here? Why not pick here or pick here? Why did you pick here? Or why not pick here or here? Why here? I know you know. Tell me why.
I wish I know.
Okay, fine. Does anybody know why Fuang picked that point? Why?
You can just cancel this R force because it's on the...
That's it. When we calculate the turning force, we don't need to consider the or because it is through the point. So we only need to consider this one and this one. Is this clockwise or anti-clockwise? Compared to here, it is clockwise. And this one, is it anti-clockwise or clockwise? It's anti-clockwise because compared to this point, it's trying to turn it against the clock. I know at least one person here is thinking, I didn't quite get that because it's one of those things I know from experience that it's hard to picture. So picture this. Here is the center of the clock. If you draw a hand from here to here, will this make it move with the clock or against the clock? With the clock. And from here to here? Against the clock. Anti-clockwise. The clock will want to tick down this way. Maybe in your home country it ticks the other way, but here it ticks down this way. So this is anti-clockwise. Yes? All right. So, what?
So
Yeah.
you're saying if that was like the turning point,
Here. Yeah. Here.
it
Yeah.
would go clockwise, and if that wasn't there and it was only 0.9, it would go anti-clockwise.
If you had only this one, it would go anti-clockwise. If you had only this one, it would go clockwise.
But isn't it the middle? So
The center of the clock is here. That's what it means to call this the fulcrum.
okay.
I don't. That okay wasn't convincing. What are you thinking?
Isn't that
Isn't the center the center?
No, isn't the fulcrum where like the thing turns?
It's interesting because true, the fulcrum is the point where it actually turns. But in situations where it's in equilibrium, it isn't really turning anywhere, is it? Because it's in equilibrium. So you're actually free to place the fulcrum anywhere on the diagram.
Okay.
If you redid this question but placed it somewhere else, you'd get the same answer. So we imagine it's turning here, even though it's not going to. Yeah? Right, what's the equation I can make? So what's the first part? This turning force, what is it? What's the distance?
0.5.
Is it?
0.25. 0.5 minus 0.5.
Here to here. Yeah, 0.25 times 0.1 g. And then from here to here is 0.65. 0.65 times what?
Minus.
Times what? S, thank you. Don't do that, you're like, yeah. That's what I meant to say when I said the wrong answer. You might have heard 0.1, but that's just how I pronounce S in my accent. Is it? Right. So, do we have enough information now to solve this? We do. Because what can this give us? S. Correct. And then, when we have S, this can give us R. Yeah. Do you understand why it's 0.65? Because here to here is 0.25. Here to here is 0.1. Remember, the total is 1 meter. So 1 minus this and this gives me the distance we want in the middle. So I just did 1 minus 0.25 minus 0.1 is 0.65.
So what is 0.65?
The distance from here.
Or what's the formula, like the original formula before?
Turn clockwise equals anti-clockwise. And remember, the turning force, the formula is force multiply distance. Question? You have a question. I can see it forming. What's your question?
No,
It hasn't formed yet? Or you're okay?
I have a mini question.
Yeah, go on. Mini questions are good too.
Displacement, right?
S, I know, we're using it to represent tension. You might say, why not use the letter T? But then this one is also tension as well.
Which one? I don't
Both are tensions. If you prefer, you can call this T1 and T2. If it makes you happier.
Yeah, I didn't see the R and the S.
Yeah. Is okay now? Yes.
I actually don't know the distance.
Which distance? 0.65?
No,
No?
the O.
It's 1 meter.
Why do you know that in the
Ah. Meter stick.
No.
So it's a stick that's 1 meter.
Why?
Because it's called a meter stick.
What's that?
Meter stick. Oh.
That's what they call it in English.
Meter stick is a stick that's 1 meter long.
Like a ruler.
Here. You don't seem happy with this.
I think what's confusing here is what was behind the meter stick. 100 gram meter stick.
Yeah, a 0.1 kg meter stick.
But isn't that the unit? The meter is just a unit.
Yeah,
No.
but you can use it for the name. So if I call something a meter stick, it's a stick that's 1 meter long. This is new information, is it? Like for example, Fuang, if I said a 1 liter bottle,
Yeah. Oh, I know that.
you know that one, yeah, it's the same idea.
No, it's one.
I know.
Explain it using x as a mnemonic and x as a coefficient.
It's like this, yeah. But nobody says a 1 meter stick.
Why?
Because English, I don't know. Can we think of any other examples where there's a
Yeah.
unit?
Do you say 1x square or x square?
1x squared.
No, you don't. No, you don't say that. You don't say that. You say x squared, don't you? Yes. Is there anything else that has a unit as part of the name?
A
Meter.
kilogram of apples.
A kilogram is 1.
So it was 100 gram meter. 100 gram meter stick.
You could say a kilogram of apples, and if you don't say the unit, if you don't say the number, it means 1.
But it means 1. It
Okay.
means
Here. This is the one you're talking about, yeah? A meter stick.
But this is like one stick is not too big. That means like that.
I don't know what to say anymore.
She's proving your point.
Okay. From now on, we'll call it a 1 meter stick. Yes. Yep.
And also 90 centimeters.
Okay, 90 centimeters. In the question, I gave those two numbers, 25 and 90. So this is at 25 and this is at 90.
From 90.
From the very start. Yep. Okay. Can you take out your calculators and give me the F and the R, please?
partially is
For which?
X.
That seems kind of...
No.
0.04.
What is it?
0.04.
0.04. Oh, guys.
If it is, then R has to be 0.
And 0.3. Oh yeah, 0.4.
Guys, how hard is it to type in this times this divided by this?
Yeah, 0.38.
Is it?
0.038.
No, 0.38.
Are you including the G?
Yeah.
Yeah.
With the letter, the constant.
Here, look. Look. No, look. 0.25.
0.3, not 0.0.
I don't believe anyone anymore.
0.37.
Guys, just look up.
Oh.
Yeah.
Yeah,
Yeah,
and
okay.
divided by
And
0.65.
Yeah. And then,
Yeah,
yeah.
0.38.
Yeah.
Yeah, I didn't doubt you for a moment.
You not trust me.
I don't. And then the OR,
Has to be.
the OR is 0.1 times 9.81 minus answer previously.
0.601.
Yes, 0.604.
0.1 minus.
There it is there.
0.1 G minus.
Yeah. Okay. Yes? Is that okay? Can I remove the calculator now? Yeah. Right.
What is it in here?
Oh yes, newtons. It's a force. Okay. Try this one now. Try this one. So this is the first. You were asking about uniform, weren't you? Yeah. So this is an example where it's not. Draw, and we'll do it together.
sorry, just quick.
Yeah,
To find R, it was 0.1 times G.
it
minus
was,
S.
Yeah.
yeah. Let's say where must the second man go so that the beam is in equilibrium.
Where was the second man second? Was that
Yeah, it's a riddle. Figure that out. It should have said where must the second man go so that the beam is in equilibrium. How I mistyped it like that, I do not know. Anyways, that's not important. I just want you to draw the situation. Okay, drawn it. Two identical twins are just about able to carry a 50 kilogram beam of steel. This is 50 kg. The beam is 4.6 meters long. The first man is 10. Oh my goodness, come on. The first man is 10 centimeters from the end of the beam. So there's one man here holding it, and this distance is 0.1. The center of gravity is 2.1 from the end of the first man. So the center of gravity is not at 2.3, but instead is closer at 2.1 from the start.
From the end.
Yeah. So from here, the end that the first man is at.
Not the opposite end?
No, that's the end can be used this way in English to actually mean the start as well. Where must the second man go so that the beam is in equilibrium? No, because the beam is not uniform. It's the center of gravity is nearer to this man.
Yeah, I mean, we can just pick any point for the pivot end.
Yeah, well, firstly, we'll measure the distance from this end. We'll call it x. And we'll call this force here R.
What's the 2.1?
That's where the center of the beam is, center of gravity. Now, here's the trick for solving this. This here is also R. Why?
Yeah, I don't.
Yeah, there are two identical twins. So we have R plus R equals 50G. So that R equals 25G. Can you tell me what that is, please? Two
45.25
newtons. Now let's use the turning force. Where should we place the turning point?
is the center of gravity.
Yeah, it doesn't really matter. I don't know. Let's place it here. Doesn't matter. So this one, clockwise or anti-clockwise?
The one on the right or the left? Oh, this one is clockwise.
Okay.
The other one,
Clockwise,
I put you-
and this one is
Stand
anti-clockwise.
0.6 meters.
We'll see. So this turning force What's the distance from here to here?
2.
2. Or. That's equal to the distance from here to here times or.
No. From C
Here.
to A.
To here. Now we're taking this to the turning point.
Oh, okay.
Yes. 245.25. And the distance will be what?
4.6 minus 2.1 minus x.
Yes.
2.
In other words, 2.5
Minus x.
minus x then. Now what's nice here is that we can cancel this with this, and we get 2 equals 2.5 minus x.
So
X is
minus 2.5.
4 point. Oh no, sorry. What am I doing?
Minus
0.5.
Yeah. 0.5.
So he should stand 50 centimeters from the end. Is the answer. Okay. So write this one down, and then I'll give you some to try. Yes. Yes. Like I said earlier, you can put it anywhere.
So, how do you get the 2.5 from this?
Yeah. So the total beam is 4.6. True. Here to here is 2.1. So therefore, here to here is 2.5 because it's 4.6 in total. So here to here is 2.5 minus x. Yeah. Is that okay? Yeah.
Can I read the question?
Yep.
Well, what did you mean when you said you can choose any point other than 2.1?
Ah, my heart.
Maybe
Okay.
isn't the center of gravity the one we should use?
No, but you asked me this 6 minutes ago, and then he just asked me it 1 minute ago. So, just to be clear, we put the turning point here.
Can we put it at 0.1?
Yes.
Okay.
Yes.
And we'll still get the same.
Yes.
Okay.
That's what I. Yes. Yes. You get the exact same answer. All right. Did you write that down? Yes. Yep. Okay. So, some small question here for you to try, and in fact, there's probably time for you to finish it before going home. There is. So let me just close this. You can open it up on Moodle.
No.
Fine. Well, I need to stop the video anyways.